last one for the trig, so we'll have a trig quiz next week over just 7.1 through 7.4, mostly 7.2, 7.3, and 7.4, really. 7.1 is kind of like the intro. It wasn't really much solving. It'll be focused to mostly taking the derivatives. So just keep that in mind. That quiz will be, I'd probably say Tuesday. Okay, so first we examine problems of optimization involving trigonometric functions and how in many problems. So we only have 4 examples here. So this is back to the position of a particle. So we've talked about that before and how it moves back and forth, left to right, where it changes direction, all that kind of stuff. So the position of a particle as it moves horizontally is described by the equation s equals 2 sine t minus cos t, between 0 and 2 pi for its time, where its displacement in meters t is a time in seconds. Find the max and min displacements. Okay, we're trying to maximize and minimize. So if we do max and min, what are we looking for? Derivative. So first thing we're going to do is we're going to do s prime. So what's the derivative of sine? Cosine, so it's 2 cos t. Derivative of cos, negative sine, so there's a negative there, so plus sine t. That's our derivative. This is where it gets to the, if you like, I mean, we keep using this term, you guys kind of understand. This is where we get to the puzzle piece. We got to figure out 0. We're not going to sit here and plug in t's. Okay, so we're just going to set this equal to 0 here, and we're just going to kind of, like, we're going to solve and see what we can kind of do here in terms of moving things. What I mean by that is, if I go ahead and minus this 2 cos t over, and then divide the cos t back over. So it would be what did I just create? Tan. Sine over cos is tan t. So tan t equals negative 2. So if tan t equals negative 2, what can we do with that? So if tan t equals negative 2, we're going to go ahead and think of that in terms of, so tangent t, well, we could do, I mean, I don't want to show you that right now. Hold on. Let me think. The first thing we need to understand is if tan t is negative, this goes back to even math 20. Do you remember the cast rule? So where does that mean? Where are we? What sections is tan negative? These two, right? That's when tan's negative. Okay, so I'll have to look and see here, to be honest with you, but I know that, so the relationship that we're going to be given is, I wonder if I'm missing some information from above or something. Well, it can't be from above. Hold on, let me look at it one more time here. Let me see. I'll work on that. I'll get that back to you just so we can move on. I'm just having a brain lapse for whatever reason, but I couldn't remember the combo in the computer card either today, so that's good. Done it like 100 times this year, but so all you need to know is, for now, I'll get to why the root 5 happens, is that since we know what we just said, okay, we know that the negative tan's here and here, like you said, and that's between pi and pi over 2, and that's between 3 pi over 2 and 2 pi. Okay, and by knowing that, it gives me these values, and I told you that I'll figure out where the root 5 comes from. But we know up here, sine is positive, right? And cosine's negative. And down here, sine's negative and cosine's positive. So the relationship that they have in this situation is 2 over the root 5, which I said just kind of trust me on that, and since I'll tell you where the root 5 came from. And the cosine in this section will be negative 1 over root 5, which when you see that, sine over cos, that's negative 2 when I put those over each other. So the root 5 is the only thing that I'm just, like I said, having a brain lapse on, so just be patient with me on that. So then conversely, on the other side, it's going to be sine of negative 2 over root 5, and then cosine will be 1 over root 5. And so what that does is that gives us, I know why we're doing it, because that gives us values for these to plug back into the original. Because these, remember, going back to it, this still started with, we were finding critical values. So what I've done is, and like I said, the root 5 I'll come back to you on. These are what we're going to plug in to figure out our s. So this is a function of t and s. Okay, so when I plug these in to here, it's going to give me my s value. Okay, like where it comes out, like your y, when we plug an x back in to get the point. Okay, so that's what we're going to do. So when we do that, let's just do this one here. Be 2 times 2 over root 5 minus a negative, so that's going to be plus. So then 2 times, this is an awful root 5 here. Two times 2 over root 5 is 4 root 5, plus 1 root 5 is 5 root 5. 5 root 5 over 5, you can also write that if you went ahead and rationalized. It would just be simply root 5. So root 5, we're going to do the other one. Just hold on to root 5. Actually, how about this? Which region was this in? Where did we get these points from? The top one, right? And so sine, is it positive or negative here? So then what would you assume this value represents? Correct, but in terms of what they're asking, is it a max or a min then? It's a max, because it's your sine piece. It was positive, so this is going to be your max of the graph, root 5. Okay, the other one we're going to do here, when we do it, it's going to be the negative root 5. No, that's not how we found the first place. Like I said, I have to come back to that. It's like I just can't come up with the top of my head right now. So the second one, when we do this one, same exact thing. We're going to get negative 4 minus 1. See, it's going to be, if I put this in here, it's going to be a negative here, and then that's going to be a positive. It's all it's going to change. So it's going to be like this. So this would be a negative 4 minus 1. So this one's a negative 5 over root 5, which is a negative root 5. So that's your min. That's your max. Okay, so the only other thing we have to test, just to make sure that is our min and max, is what? We kind of talked about this yesterday. Because yesterday, what was our min and max from that problem I did with, like we do the curve sketching with? What was my min and max? Do you remember? The one we did all over the board? Remember, it was the endpoints? The 0 and the 2 pi. So we still have to test the 0 and the 2 pi to make sure they're not higher or lower than these values. So for example, if I put 0 in here, sine of 0 is 0. Okay, cosine of 0 is 1. So negative 1 is what I'd get here. Is negative 1 smaller or bigger than root 5 or negative root 5? No, negative 1 is right between them. Okay, if I put in 2 pi, again 0 for sine, and then this time I get 0 again, negative 1, same answer. Again, that's in between them, so it doesn't affect. Okay. Okay, again, apologize. I'll figure this out by the end of the day when we're, like I said, we'll try to go see Tatum here in half an hour and I'll figure it out. Okay, all right, so let's go on to this one. Find the maximum perimeter of the right triangle with hypotenuse 20. Okay, I think I had both ways of doing this on here. Yeah, so one, we'll do it the first way, is going to be without sine and without trig, and the second way will be with trig. Okay, so the first way without trig, the second way with trig. Okay, so how do we maximize perimeter? So I've already kind of drawn it. So find the max perimeter of a right triangle with hypotenuse 20. So here's 20. I got x. So we know, what do we know about x though? Does x have limits? Like in terms of what x can be? Has to be less than 20. So we know our, essentially, has to be greater than 0 and less than 20 is our restrictions on x. Okay, x can't be bigger, or it can't be equal to or bigger than 20. So then we'll call this h. Our expression for h, if I want to solve for h, would be h equals the square root of 20 squared minus x squared, right? Our perimeter is 20 plus x plus h. So this goes back to kind of what it says. We want to figure out what we're comparing, and then we want to get everything with one variable. This one I kind of set up so we can put it with one variable pretty easily. What will we do now? Just boom right there. Because now we have all x's. So perimeter is 20 plus x plus, I'll change that to 400 to 20 squared. And now we want to take the derivative of that. We're maximizing, right? So p prime, gone, 1, that's to 1/2, right? So I'm going to go plus 1/2. Okay, I'm going to keep it, I'll keep it with the exponents for now, but I'll move it down in a second. But we also have to do the derivative of the inside, which would be the 2x, right? Negative 2x. So derivative of 20 is 0. Derivative of x is 1. This is something to the 1/2, so drop the 1/2. Subtract 1 to get negative 1/2. Derivative of the inside is negative 2x. So essentially, this 2 and this 2 essentially cancel. So this is going to look like this. 1 minus x over 400 minus x squared to the 1/2. Okay, or you can leave it up, it doesn't matter. So what are my critical numbers? Say that again. Positive negative 20, yeah. What's that? 0, because 0. So, but the thing is, hold on. Before we do that, Nikita, we have to remember, if that's 0, it's 1 minus 0, though, because of the 1. So we want to either put the 1 together or solve. So we can also solve this. So don't forget, let's write this on the next page and solve it. So if I have 1 minus x over, thanks. Remember, this is equal to 0 for finding the critical numbers. So we can just solve. So what I mean by that is I can minus the 1. Since that's negative, it's really, they're both positive. It's a positive 1. That negative's there, yeah. It's going to be, yeah. So then I'll change that. Like that. I'll times this over. Okay. So now the thing I'm going to do is I'm going to square everything, because this is kind of my issue. So if I square this and square this, then I just kind of get rid of that problem. And so I have x squared equals 400 minus x squared. And now we can solve this, like, completely. I added that over. Divide 2. So our critical values are plus or minus root 200, or plus or minus 10 root 2. Those are our critical values. But in this case, we don't take negative 10 root 2 because we've been talking about length, the length of the triangle. Okay, so let's recap here just what we did there. Yes, but the problem is this 1. So if it's undefined, yes, but yeah, you can test those, but it's not. But 20 can't be used because it wasn't in our domain. It couldn't be equal to 20, so that's why we declined that. Okay, good point. I'm glad you brought that up. So back to what we're doing. We're maximizing the perimeter with a hypotenuse of 20. So we want to know the biggest possible perimeter we can have, the hypotenuse of 20. The reason that is something you can maximize is because it has limits. We can't have 20 down here at all. Okay, so then we're going to go through and we're going to see 10 root 2 is going to be our critical value we're going to test for our x. That's maximizing x. Okay. So then we confirm with the concavity that it was the switch. I think I'll skip that for now. So 10 root 2 is the max for x. That's the biggest x we can have. But 10 root 2, what is 10 times root 2? Does anybody have their calculator out by chance? Can you do that real quick, Jerry? What's 10 times root 2? It's probably pretty close to 20. 14.14, so 14.14. Not quite as close to 20 as I thought it was going to be, but that would be your length for x. Okay. Any questions on that? Okay, so now we're going to just change the gear, and we're going to do it with, we're going to use trig with it, which is kind of the main point. That's why I'm not doing the concavity part for the second one. So what we're going to do to help use trig is we're going to let this be an angle theta. So we're going to use trig in the sense of, like, y over 20 is what? Which trig is that? Sine, right? X over 20 is cosine. Good. So we're going to write that. So x over 20 is cos. Y over 20 is sine. So if I solve for x and y on those, that means that x equals 20 cosine theta. Does that make sense? Just times 20 over. Y equals 20 sine theta. Because remember, we're still trying to maximize x essentially. So that means our perimeter is 20 plus 20 cos theta plus 20 sine theta. Then we're going to take the derivative of that. That's gone. That's going to be negative 20 sine theta plus 20 cosine theta. So essentially what you're going to see, remember our critical value is when it equals to 0. Maybe if you just look at this, what do you notice about this here? Just look at this generally. What does that say? What is if negative 20 sine theta plus 20 cosine theta equals 0, what does that mean? Just generally speaking. Well, they have the same coefficient, right? But we don't know what sine cosine is, but obviously they're equal. That means they're equal. So, because if I add 20 sine theta over, you're going to have 20 sine theta equals 20 cosine theta. So essentially we're saying sine and cosine are equivalent. Okay? So that's what we'll work down to. So where are, on the unit circle, are they equivalent? 45s, pi over 4. Okay. All right, so pi over 4 essentially would be the maximum value in terms of plugging it in. So if I put pi over 4 here, so let's do this really quickly. What is, so root 2 over 2, is it pi? What's 20 times root 2 over 2? Jared, can you do that for me? What's 20 times root 2 over 2? It's probably going to be 10 root 2. What? 20 times root 2 over 2. 20 divided by 2 is 10. My point is we should get the same answer. Trig might be easier to you. Okay. If you're not sure how I got the root 2 over 2, if you take pi over 4, this is what x is, right? You put it in right there. Cosine of pi over 4 is root 2 over 2. So you do that, you times that by 20. That's what I was doing right here. Pi over 4 is theta, yes. Plug that into where? If your calculator, you put pi over 4 into those. Yes, you put them into both. But when you put them both, you're gonna get the same answer, right? Yeah. That's 10 root 2. So if we do 10 root 2 squared, like if we just proved it, essentially, and this is kind of redundant, I guess you could say, to maximize it, we're saying that x and y have to be 10 root 2. To prove it, we can just show that they're equivalent. So if I do that, that's going to be 100 times 2, 200. 100 times 2, 200. 200 plus 200 is 400. 20 squared is 400. So that's just proving that those are the right setup. Okay. All right. All right, actually, I want to pause here to give you guys a figure out.